All right, let's give this technique a try. So step one up above was to find the reference angle. So before you can find the reference angle, it's a good idea to actually sketch the angle that you're concerned with. So we're at 7 pi over 6 here. And this should be just past pi radians, right? 7 pi over 6 is just a little bit more than pi radians. It's an extra pi over 6 actually, which is the number that we're going to compute right now. So yeah, we're looking for this angle here. Actually, that's not entirely true. We already have that angle. We're looking for this one here. That's what we're looking for. But we know that it's pi radians to do a half a revolution. We know that the angle we have is 7 pi over 6. So the angle that's really kind of snuck in between those two, or stuck in between those two, is going to be given by 7 pi over 6 minus pi. And so that's just going to give us pi over 6. So I'm actually going to get rid of some of this now. And I'm just going to write in our reference angle, pi over 6. Okay, and this creates a triangle. Okay, that's going to be our next step, to draw in a triangle. Okay, and this triangle should be familiar. You actually know that this other side should be pi over 3. This is the 30, 60, 90. Okay, and we know the side lengths of this thing. Okay, if we scoot up, if we've forgotten them, opposite of the pi over 6 should be a 1. There we are. Should be a 1. The hypotenuse should be a 2. And opposite of the pi over 3 should be a square root of 3. These are just the side lengths of the triangle. Okay. Next step. We want to use Sohcahtoa is really what the next step is here. And let's go and do that. So we started off, by the way, with cosine of 7 pi over 6. And we've broken this problem down into a simpler one. We're going to try and just find cosine of pi over 6 using that triangle down there. And notice I did leave a little gap here. We're going to have to potentially include the sine here. So I'm going to leave that gap there. And now if we look at this triangle, ca adjacent over hypotenuse, that is the square root of 3 over 2. The only thing that we actually need to think about here is what is the sine of cosine in this quadrant. Okay, and that's confusing because I said the word sine, but I didn't actually mean S-I-N-E, I meant S-I-G-N. I want to know, is cosine positive or negative in the third quadrant? Since we're below the x-axis and to the left of the y-axis, both x and y values are negative in quadrant 3. But more importantly, the x values are, so that means that the only thing I need to do here for my answer is include that negative there. So you might be wondering why what we did worked. Why does this work? Okay, let's look at a picture and see why. So here's a picture of our unit circle and of our angle 7 pi over 6. And let's real quickly sketch in also the triangle that we used. It's just a bigger version of it. Okay, there we go. And if I were to go back over, I would see that opposite of my pi over 6 was 1 again. Okay, so let's write that in here. So there's my pi over 6. Opposite of that should be 1. along this side here should be the square root of 3, and the hypotenuse was 2. Okay. But now I want us to look at another triangle, okay, one that we actually came up with first. It was still actually the 30, 60, 90. It was just scaled a little bit differently. Okay. And actually I can remind you of what that is just by having you think about the unit circle. So if we were to mark this point right here, you know that the y value here should be minus 1/2. So that would mean that length would be 1/2. And if I were to go this way, you'd know that at least at this point right here, you'd know that the x value is minus the square root of 3 over 2. And since that's the case, we know that this side length here is is the square root of 3 over 2. Okay. Now notice the purple triangle here has side lengths that are just half of the ones for this black triangle. Okay, but they both have the angle pi over 6, and they're similar triangles. Okay. And the fact that they're similar means that no matter which one of these triangles I use, whether I were to use, say, the one here in purple, if I were to find pi over 6, okay, and I were to do adjacent over hypotenuse, so that's the square root of 3 over 2, and then all divided by 1, right? Right, the hypotenuse of this smaller triangle was just 1 because it's on the unit circle. I get the same thing there that I get when I do cosine of pi over 6 using the black triangle here. Okay. If I do adjacent, I'll get the square root of 3, and then if I do over the hypotenuse, it's over 2. Okay. And it's because, again, similar triangles have the same ratio of sides. So even though it doesn't seem like we're actually using our unit circle anymore, we really are. Okay. Let's go ahead and try another one. So we have cosecant of minus 5 pi over 4. And before we sketch that, let's again find something coterminal with it. Well, we could just add one period to this and see if it's enough. Let's see if it is. Okay, so that's going to be minus 5 pi over 4 plus 8 pi over 4, which is 3 pi over 4. And then we can come in here and we can sketch that angle instead. We don't need to sketch this minus 5 pi over 4. Okay, and then 3 pi over 4, that is 1/8 of a revolution short of pi radians. Okay. And so maybe I just gave away a little bit what the reference angle is going to be here, but the idea is we're looking for this angle here. Okay. So if we want that, if it's pi to get to here and 3 pi over 4 to get there, then what we're left with here must be pi minus 3 pi over 4. That must be our reference angle. So pi over 4. Let's get rid of all this and we'll put in pi over 4 there. And once again, this creates a triangle. And if you were to go back to the last page, you'd see, well, opposite of pi over 4 should be a square root of 2. And, well, this side's also square root of 2, and then the hypotenuse was 2. Okay. So the next step, let's remind ourselves what we were actually trying to find. We were trying to find cosecant of minus 5 pi over 4. And is what we decided to do instead, I'll leave a little room just in case for the sign here. So what we decided to do instead is to look at cosine of pi over 4. Okay. And you know, it might even help if instead of thinking about this as cosecant, maybe we think about it as just 1 over sine. That might be even easier. Okay. But we can do that in a minute. How about right now? 1 over sine of pi over 4. Okay, so that makes it easier. It's a little easier to work with sine and cosine. All right, so our next step here is to think about that sign. What should the sign be in this quadrant? And I'm actually thinking about sine. So what's the sign of sine? Sine is positive in quadrant 2. So maybe I'll write a little plus here and just note sine is positive in quadrant 2. All right, and so that means I don't need to write a negative in here. So I'll just leave this as 1 over sine of pi over 4 for the moment. And the next thing we'll do, and let's keep it in the same color, is use that triangle to find sine of pi over 4. So sine, that's opposite over hypotenuse. So if you do that, you get the square root of 2 over 2. And if we were to simplify this a little bit, this is going to become 2 over the square root of 2. And I realized I was just running off the page here a little bit, or into the next problem. Let's just go ahead and write it right here. 2 over the square root of 2. And you could rationalize this. This would be 2 root 2 over 2, okay, which is just root 2.